Ty Warner with Tyke Engineering and KISSoft Tech Support. Some questions on operating backlash. Generally in KISSoft, we have a report. So if you have a gear pair or a planetary pair or three gears train, etc., we have our general report. So if I open up a gear pair down here in the examples, I'll just grab this first spur pair. We're going to open this and we're going to look at, we have some results here on the bottom. If I hit and run this, our calculation is consistent down here on the bottom right, and I can generate a report. And in the report, we have all this information here, right? There's a ton of information. But right down here at 13.5, we have backlash. And if I click on this, we get circumferential, radial, normal, the center distance allowance, etc. So this is what you would normally see on a nominal gear pair coming out. When you add in the center distance tolerance and the tooth thickness tolerance, this is the normal backlash you would expect to see. Okay, this is at your manufacturing temperature, so assume it's room temp. But what you want to know is what happens at temperature, maybe minus 40, minus 20, whatever that might be. And so there's a module in KISSoft. If you don't have it, you can purchase it, of course. But there's a module called Operating Backlash. And when I click on this, I get a new window, Operating Backlash window. And here we can consider manufacturing deviations. We can consider axis deviation error, accuracy class, distance between bearing centers. If you've already attached or connected your shafts in the factors tab, like if you've done this axis alignment, you've connected a couple of shafts here, which we could do. We can take that account for the bending of the shafts and the flank line modifications as well. So here's what we say. The reference temperature is the room temperature. This is what you manufacture the gears at. Say it's 20 degrees Celsius. And then your temperature range for the housing might be, minus 20 Celsius to 50 degrees Celsius max. And you can, of course, right-click and change that so it's 4 to 122. And then you have the same thing for the gears. So let's say that this thing runs outside and you're worried about you're worried about this thing starting up in the cold. Like you're worried at minus 4 degrees, are you going to stick the gears or something like that? There's going to be damage. And then you give it a permissible temperature difference. So here we say it's 20 degrees between the housing and the gears. We don't know if it's going to, sometimes the gears could be, they warm up quick with oil, right, when it starts shearing and creating heat. And then you can define your housing material. So maybe it's a structural steel, and there's a list that you can choose from. Maybe it's this, I was thinking it was going to be an A36. I don't see it in here, but this 284 grade D, this is fine, right? And then there's a coefficient of thermal expansion based on that material, all right? So what this is going to do is it's going to look at the temperature difference on the housing and the temperature difference in the gears. If it's a plastic gear, there might be some water absorption. You can enter that or to calculate it. You can reduce tolerance ranges. You can turn this off, like if you don't want to consider the axis deviation, but that's like, the axis is moving up or down depending on either side there. And then, so now you're looking at this report. So when I run this, okay, I'm going to get a report. And the report is my circumferential backlash, plus or minus. This is my smallest operating backlash. This might be at the cold temperature. And then the biggest operating backlash is going to be here. And that's going to be at my high temperature probably. We also have torsional angle fixed with fixed gear 1 for both of these as well. Okay. Now you want to know what is the normal backlash, and you just go ahead and run this report while you're on this tab. And when you run this, you get a backlash operating report here. Okay. Get this a little bit bigger. It gives you a housing temperature max and min. It gives you the center distance tolerances that you have, your tooth thickness allowance. It gives you all your inputs right here. And then here's your results. So you get a housing thermal expansion, change of backlash to the center distance tolerance, right? So your plus or minus. And then down here, you have your theoretical backlash. You have circumferential. So I could put that down on one page. Your min, your max, your theoretical backlash and operating pitch, your min and your max, and your acceptance backlash, your min and your max, okay? Now, you can use this information however you need to, really. This is kind of like the big takeaway. But if you look down further in the smallest operating backlash, you're going to get your normal backlash right here, okay? And you have radial backlash, and then you have the torsional with gear 1 or gear 2 fixed, okay? And then you also have some information here about the change of your pitch error due to dilation, and that'd be more or less if it's a plastic gear or gear that might absorb water and swell. So, and then you have your biggest operating backlash. It gives you the temperature, the housing temperature, and the combination. All right. So up here it was minus 10 and 20 for the smalling, or the smallest. Biggest operation is minus 20 and 10. I wouldn't have guessed that, but that's what it is. And then your circumferential backlash and your normal information. Okay. And then there's this proposed tooth thickness allowance and center distance allowance. So it gives you the possible, these are proposed values to give you the smallest possible center distance allowance or the smallest possible tooth thickness allowance. And you can adjust these, and I'll show you where those are. I'm not going to save that, but that's right here on the bottom of this. Okay, it's a proposal for minimum, down here, minimum tooth thickness and center distance. Okay, and you can, if you click this, it'll change the tolerances. So right now my center distance is plus or minus 16 microns, and if I click on this, it's going to be plus or minus or minus and minus, looks like. So if I change this tolerance, it asks me to change the center distance or the tooth thickness. Okay, and I can pick on one of these. I don't think I would have this kind of a center distance allowance, so maybe I would adjust this tooth thickness, and if I adjust that and then rerun it, it maximizes the tooth thickness, and this is now my smallest operating backlash. Okay, so you don't have to use that. You can do your own playing with the tolerances here with the tooth thickness or the center distance, but so it's kind of a generally how I would approach this is I typically have a center distance and I have a center distance tolerance that I know from manufacturing, and I would keep that, and I might adjust these tooth thicknesses to what I need, and then I might check this also and say, okay, well, here's my tooth thickness. Does it look reasonable? Did it give me an undercut? Did it change something that's going to be weaker than it was before? You might look at your basic calculation and say, well, no, it looks like the root safety is good, the flank safety is good. I think we're okay. So that's a quick look at operating backlash in KISSsoft. And this is version 23 SP4. It's going to be similar in version 24 when it comes out next month. But this is kind of how you'd approach that. And again, you can consider runout. If I click this on, it automatically calculates this runout based on your quality class right here. Okay. And if you want to change it, you can select here and change it to whatever you want. Now, if we run this, it's probably going to be tight. I'm guessing, yeah. And now I have another center distance allowance. So if I change this and I use the top, run this again, you can see I've got 0 backlash at the minimum, at whatever. That's the smallest backlash that I would have. So, and it works. So this is, I mean, these are ways that you can play with this tool and kind of set your backlash to get what you want. So hopefully this is beneficial. There's been a couple questions, but it is really a pretty handy tool when you have multiple gears in contact and you've got a large temperature swing in the environmental conditions for these gearboxes. And this is a really quick way to check your backlash so you don't run into problems down the line. Hopefully this is helpful. You can go ahead and subscribe to the channel if you like. You can like it. You can do nothing. You can call with questions or whatever. But I think this would be pretty handy if you're doing full system gearbox design. Feel free to reach out anytime you like. Again, it's Ty Warner with Tyka Engineering and KISSsoft Tech Support. Thanks.